In this video, we're going to learn a little bit more about friction. We'll understand the difference between static and dynamic friction, sometimes known as kinetic friction. We'll investigate friction in a moving object. So, as you already know, friction is a force that opposes the motion. If you're going in one direction, it will go in the opposite. There are two types. We have static friction, which stops a resting object from moving. Then you have the kinetic friction or dynamic friction. This is to oppose the moving object when it's already in motion. You must know that kinetic friction is less than static friction. When I apply a force, as I keep making a stronger force, the static friction gets stronger. If I have a much stronger force, the static friction gets even stronger. If I get to a certain point where this friction will not hold anymore, it starts to move. Right here is where it starts to move, and straight away the sliding friction or the kinetic friction will become less, and that becomes constant after that. It will never change. That was almost a perfect line. Okay, so there's a quick formula if you wanted to know the total force of an object. If I am applying a force, let's say to the left, let's say this is 100 newtons, and then I have a friction stopping me, and the friction force is 20 newtons. The total force will be applied minus my friction. Fs means static. Fk could be kinetic. Doesn't matter which one's which. If you've given the number, then you just subtract the two. Why? Because they're in opposite directions. This will become 100 minus 20, and the overall will be 80 to the left. 80. The arrow will be a little bit smaller. There we go. So, for friction, when you push, the static friction also increases because it's trying to oppose the motion. When it can't get higher, it reaches Fs max, maximum static friction. Then it starts to move when the pushing force is bigger than Fs max, and then it now has Fk, which is smaller than Fs max. That's important to know. This is smaller than the static friction. So something to think about is if you're trying to get something moving, it's hard to make it start moving, but when it's already rolling, then it's easy to continue moving, I should say. So this is what friction looks like. If you zoom in on something, the contact area between two surfaces, you can see that there's little bumps and grooves, and that's when these two things are rubbing together. It has to get past these things. It gets stuck, essentially. And just one final note again, it is always in the opposite direction of the movement, okay? And it always depends on how rough the surface is and how heavy the object is. The harder the object's pushing into the ground, the harder it is to make it move. So that's when the coefficient of friction comes from. It's the relationship between the normal force and the surface. Essentially, the relationship between two different surfaces. Of course, there's gravity pulling this down, pushing it down. Gravity, W equals mg. If I calculate that, I know my normal force pushes up, and the normal force is the same value as the gravity force. So if this was 100 newtons pushing down, the normal force will be 100 newtons pushing up. This is the force that we use. We use the normal force for this. It's the same in this case because it's horizontal. It's not a problem here. So, quick question. Does the area of the box touching the ground make a difference to the friction? If I had different shapes, the same object but switched on its side, same object but upside down, will it make a difference? No, it will not. It only depends on the weight of the box, or whatever this is supposed to be. The weight, which is going to be the same as the normal force in this case. So, if we have a bigger mass, then the normal force will be bigger, which means you'll have a bigger frictional force. Static friction, we can use this rule here. The mu is the coefficient of friction, the relationship. Fs divided by Fn. Or I rearranged it to this. F equals mu F. Fuff. F equals mu F. This is the normal force. Mu multiplied by the normal. Your calculator, you can use shift calc if you like, and you can figure everything out just by doing that. So, for kinetic friction, it's exactly the same, but I'm not writing S anymore. I'm just writing Fk. So that's all I'm doing. The formula is exactly the same. Okay, it's Fuff. Here's an example. 24 kilogram box is resting on the floor. It needs a force of 75 newtons to move it. What is the coefficient of static friction between the box and the floor? Well, we can use the mu s equals fs over fn, 75 over, well, I don't have fn yet, but I do know this is a mass, so that's m. I can do mg, can't I? Mass times gravity, gravity is 9.8. We're not worried about the negative sign on that, this is just an absolute number, a value that we need, so I'll just do 24 times 9.8. Solving that, I will get 0.32. There is no unit for this because it's just a number. It is just a relationship. Because I'm dividing two forces, the unit will cancel. If I do n divided by n, this n and this n will cancel anyway. Just the number. And it's usually smaller than 1. For most things, it's smaller than 1. So if you've got a big number, there's a good chance that you've made a mistake. You need to check your numbers, make sure they're in the right place together. Here's a quick table to show you some things. If you were to take rubber and glass, that is the biggest, and that's 2. You know what I mean? So that is, the coefficient of friction is 2. More than 2, I would say. Rubber on concrete, it's 1, and if once it starts to move, you see it gets a little bit less. Steel on steel, 2 metals together, you get this, and then the coefficient of kinetic will be less. And here a bunch of different options. You will be given the value for mu in an example, or you would have to calculate mu. So either way, you will have 2 pieces of information to help you find the third. The last thing we need to know a little bit is about free body diagrams in this part. So if I said to you, we have a box on a table and Amna tries to push the box to the right using all of her force, even with 14 newtons, nothing happens. Draw a free body diagram. Okay, so I will not need to do this and draw the box and then draw Amna. What's this? That's going to take too long to draw. Got the little hijab there, very nice. And she's trying to push it to the right, so she's applying a force that way. And it's not working, which means friction is pushing against. This is too much to draw. All of this, I will condense it down into a tiny point. I will have that. That's my free body. That is everything. There's nothing I need to draw except the dot. We did say she's pushing to the right with 14 newtons and nothing happens, so that'll be 14. The arrow pointing to the right. So there must be friction going to the left, and the arrow should be the same size because it's the same value. So don't draw a tiny arrow to the left, draw the same sized arrow, okay? You can also realize that it's resting on the ground, so we do have the gravity force, the weight of the object, whatever it might be. It's not important. We also have the normal force pushing up because, of course, the box is not falling into the ground. There's no mention of it going downwards. So my normal force is the same as the weight. This is a quick free body diagram for that. And here is another example of a kinetic friction. Let me just erase that one now. We're trying to see somebody, Mira, is walking past, pushes the box easily to the left with a force of 20 newtons, and the kinetic friction is 12. Same idea now as what we just drew, but now what I'm going to do is I'm going to have an arrow 20 newtons to the left, and this is 20. But to the right, the friction's only 12, so it'll be a smaller arrow, like a smaller arrow, maybe half the size or something like that, just to show that it's a different size. You still have your gravity, and then you will still have your normal force. If it's floating in the air, or if it's something is flying, there will not be a normal force. You will have something else instead, so keep that in mind. This is only because the box is sitting on the floor. Thank you.